The processor, also known as a central processing unit (CPU), is a silicon integrated circuit (IC) of thousands or millions of transistors made up of two large units, a control unit (CU) and arithmetic logic unit (ALU). The control unit controls the data transfer between the processor, memory and hardware devices, as well as the work of the ALU. The arithmetic logic unit performs the calculations, executing its own machine code instructions issued by the program stored in the memory sequentially, one after the other. In both units, the data is stored in registers, temporary storage, the size of which is usually the same as the size of the data bus. The arithmetic logic unit contains, among other things, the general storage register (AC) accumulator, in which it stores the memory address, memory location of the second operand, variable value of the current operation and the result of the operation, and the condition register, whose flag bits, place values, show the characteristics of the state based on the result of the operation. The zero flag indicates that the result is zero. The overflow flag indicates that the generated number is larger than what is represented in the given type, in the form of the given length possible, overflow, etc. The two most important registers of the control unit are the instruction counter register, PC, program counter, which stores the memory address of the next instruction of the stored program, and the instruction register, IR, which receives the instruction to be executed retrieved from the memory for the duration of processing. PC processors are basically CISC, complex instruction set computer, structured, meaning they work with many and complex instructions, unlike RISC, reduced instruction set computer processors, which have few small instructions. However, newer Pentium Pro processors also have RISC features, such as is to analyze the scope to determine the most commonly used operations required and to optimize data lines to process instructions as quickly as possible. CISC was formed in the late 1960s, RISC in the early 80s. Most mainframes are RISC-based. Newer versions of the old PC processors can be supplemented with an arithmetic coprocessor, a coprocessor, which contains floating point number representation instructions and mathematical operations, working with real numbers. Today, starting with the 486DX processor, this coprocessor is built into all processors, except intentionally downgraded versions like the 486SX. The processor has its own internal bus system that mates with the motherboard bus system. The data stored in the memory is accessed via the address bus and transported to and from the hardware devices via the data bus. It controls the hardware devices via the control bus and receives requests from the hardware devices via this. It synchronizes these processes based on their clock frequency, i.e., the data is delivered by pulses according to the frequency. Older processors have a clock equal to the clock, or quotient, of the motherboard clock generator chipset. Newer processors, starting with the 486DX2, use this FSB, front-side bus, clock for multiplication. This value, in megahertz, strongly affects the speed of the processor. Processor speed is primarily determined by how many instructions or operations you can perform in a given period of time. It can be measured by the number of instruction executions per second. This is the number of operations executed with MIPS, million instructions per second, or integers per second. This is the number of operations executed with MOPS, million operation per second, or floating point numbers per second. This is MFLOPS, million floating point operation per second. Each instruction is processed at a different time. In normal serial instruction processing it takes approx. During 2 to 5, i.e. on average 3, clock cycles, but in practice this can be much lower, even slightly higher than 0, using different acceleration procedures. With overlapping instruction processing is broken down into subtasks of nearly the same duration that are related to different resources, thus achieving parallel processing, new, complex instruction sets, and different accelerator circuits. The speed is greatly increased. The value of MIPS is obtained by dividing the clock frequency of the processor by the processing time of an instruction. A 12 MHz 8086 processor takes approx. 4 MIPS, a 75 MHz 486DX4 processor for approx. 66 MIPS, a 500 MHz K623D processor for approx. 1000 MIPS speed. The processor also features power consumption, watt. The higher the power consumption of the processor, the more it heats up, so the more it needs to be cooled. Older processors are only a few watts, but newer ones can reach 40 to 50 watts. The oldest processors do not require separate cooling. Generally, processors with a clock speed greater than 40 MHz must be cooled by a heat sink, and processors with a clock speed greater than 80 MHz by a cooling fan with different characteristics and strengths, depending on their power consumption. Of course, there are other cooling options, e.g. water cooling, but the heat sink and fan are the most reliable. Some processor types can be tuned, which means that you can set the motherboard clock or multiplier, or both, to a certain level higher than documented without the computer becoming unstable. This, in turn, results in a large amount of heat to the processor and other components, so more cooling must be used. A particular type of processor can only be inserted into the appropriate motherboard. In addition to the processors, the 386 and later motherboards include a cache, which increases the data transfer rate of the processor by pre-reading between the main memory and the processor. Some 486 and later processors also include an integrated internal cache, achieving higher data rates. The latest processors have more integrated caches, making them even faster. Most Pentium II and processors available today also include a second-level cache, 2-Lyra cache, which speeds up processor performance tremendously. The first PC processors were manufactured by Intel on behalf of IBM, but were later manufactured by several companies. Today, in addition to Intel, AMD, Advanced Micro Devices, and VIA make processors. Released in 1979, the 8086 processor, the XT's address bus, is 20-bit, so it can address 1 MB. Its data bus can carry 16 bits, or 64 KB, at a time, but it only connects to an 8-bit data bus motherboard. It is part of the motherboard, it cannot be replaced. Hours 4 to 12 MHz. The 80286 processor, the AT, was released in 1982. Its address bus is 24-bit, its data bus is 16-bit, and the motherboard data bus is also 16-bit. Its clock is 6 to 20 MHz. This processor is already capable of performing several tasks simultaneously, i.e. multitasking. A multitasking operating system is required to take advantage of this. Newer types of processors, and most of the processors created after that, are no longer integrated into the motherboard but are housed in a separate socket, meaning they can be replaced on the motherboard. Manufactured in 1985, the first 386, the 80386DX processor, has a 24-bit address bus and a 32-bit data bus. It has a minimum of 8 KB of external cache. Its own motherboard also has a 32-bit data bus. The clock is 33 to 40 MHz. Processors with a clock speed greater than 40 MHz are equipped with a heat sink, which dissipates heat generated due to the fast speed. The later 80386SX is a downgraded version of the 80386DX. Its address bus can be mounted on a 24-bit but 16-bit data bus motherboard. Its speed is 25 to 40 MHz. Released in the early 1990s, the 80486DX processor has a 32-bit address bus and a 32-bit data bus. Includes an integrated, built-in, coprocessor. It usually has 256 KB of external cache, some models also have internal cache. It has a clock frequency of 33 and 40 MHz, respectively. The later developed 486DX2 doubles the clock of the base, so it can be clocked at 50, 66 or 80 MHz. The 486DX4 also reaches 75,100 MHz. Processors above 80 MHz have not only a heatsink, but also a heatsink. The 80486SX, the upgraded 486, has a 32-bit address bus, a 32-bit data bus, and 8 KB of external cache, but no coprocessor integrated. The clock is 16 to 33 MHz. The 486SX2 doubles the 25 MHz motherboard clock signal to reach 50 MHz. The 486SLC has a 32-bit internal data bus and can be integrated into a 16-bit 386SX motherboard. It has 33 and 40 MHz versions. The 486DLC also has a 32-bit data bus but is for a 32-bit 386 motherboard. In 1993, Intel developed a new 64-bit motherboard processor, which it called the Pentium, not the 586, due to the termination of its contract with IBM. Its address bus and data bus are both 64-bit. It can be mounted on a new 64-bit data bus with a 66 MHz FSB motherboard, the square processor socket of which has been named Socket 7. It includes a coprocessor and 16 KB of integrated cache. The speed of the first Pentium series is 60 MHz, the newer ones reach 200 MHz 5x86 processors from various processor companies, e.g. AMD and Cyrix, can be mounted on the 486DX4 motherboard. Although they can reach 166 MHz and have a 64-bit data bus, they are much slower than the Pentium, mainly due to the motherboard's 32-bit bus system. The 5K86 or K5 is a product of AMD. This processor can also be mounted on a 64-bit Socket 7 motherboard. Its clock speed is 75, 90, 100, 150, 166, 180 and 200 MHz. It was intended as a competitor to the Pentium, but slower than that. The Pentium Pro was released in 1995 and was not widespread due to its incompatible design. The clock is 150 to 300 MHz. From this processor, RISC technology is also used in PC processor manufacturing. Cyrix 6x86 Socket 7 motherboard Pentium clone. It has a clock frequency of 80, 100, 110, 120, 133, and 150 MHz, but is also slower than the Pentium. In 1997, Intel launched a new second-generation Pentium, the Pentium MMX. This processor has new MMX, multimedia extension, instructions to help multimedia applications, resulting in significant acceleration. This MMX technology is used by all subsequent processors. Depending on the type of clock, 133 to 266 MHz in response, in late 1997, Cyrix released the 6x86MX, which contains instructions compatible with MMX instructions. The frequency of its latest type reaches 200 MHz, which is a speed lower than that of the 200 MHz Pentium MMX. Enclosed in a plastic box, the Pentium 2 is an upgrade to the Pentium Pro and Pentium MMX. It can be inserted into a new motherboard, whose slot 1 socket is not square but rail-shaped. There are two types of processors, Klamath and Deschutes. Klamath was released in late 1997 with a clock speed of 200 to 500 MHz on a 66 and 100 MHz FSB frequency slot 1 motherboard. Production of Deschutes began in 1998. It can also be mounted on 66 and 100 MHz slot 1 motherboards. Its frequency is 233 to 450 MHz. Both types of processors have 512 KB of internal 2-lira cache. Also produced in 1998, the AMD K6 is a clone of MMX. Its speed almost reaches the speed of the same clocked Pentium MMX. Its frequency is 166 to 300 MHz. The Covington-coded Celeron is a redesigned version of the Intel Pentium 2. It operates at 266 to 300 MHz on a 66 MHz slot 1 motherboard. Because it has no cache, it is much slower than the Pentium 2. The AMD K623D processor includes new special graphics instructions, 3D that speed up three-dimensional programs. This is all used by newer AMD processors. Its first models can be mounted on a 66 MHz Socket 7 motherboard with a clock frequency of 266 to 533 MHz. They outperform the Celeron, but are slower than the Pentium 2. Newer models already use the new 100 MHz Socket 7 motherboards and work at 350 to 550 MHz. Although they do not include 2-lira cache, but if the programs take advantage of 3D instructions, as in DirectX driver version 6 and later, are then clearly faster than the later Celeron A. In addition to the traditional 1-lira integrated cache, the Celeron A, Mendocino, already has 128 KB of integrated 2-lira cache memory, making it much faster than its predecessor, the Covington Celeron. It operates on a 66 MHz slot 1 or later Socket 370 PPGA motherboard similar in shape to Socket 7, but with a completely different architecture, with a clock speed of 300 to 533 MHz. There is a converter with which the compatibility of the two socket types can be solved. Cyrix MAI is an enhancement to the 6x86MX. Suitable for 66 and 100 MHz Socket 7 motherboards. Its frequency can be between 300 and 333 MHz. It uses a non-standard frequency of 333 MHz, triples the 83 MHz FSB. Production of the Pentium III Katmai began in 1999. It has a special, similar to 3D but shorter plus instruction set, SSEC. Suitable for 100 and 133 MHz slot 1 motherboards. Contains 512 KB of 2 Lira cache. Hours 450 to 600 MHz. The AMD K63 fits into 100 MHz socket 7 motherboards. Like the Celeron and Pentium II, it has an internal 2 Lira cache. The clock is 400 to 450 MHz. Production of the K63 processors was completed after the release of the K7. Released in the second half of 1999, the AMD K7 Athlon took the lead in the processor speed race. Its clock range is from 500 MHz to 1000 MHz. New USB Slot A processor socket, 100 MHz DDR motherboard. Uses 256 KB or 512 KB of internal 2 Lira cache. Intel's enhanced Pentium III Coppermine rivals the AMD K7. Can be fitted to a 100-133 MHz slot 1 and later Intel socket motherboard in an FPGA socket. Its frequency is 500 MHz to 1.13 GHz. The AMD Athlon Thunderbird processor has been in production since the first half of 2000. It has 256 KB of 2 Lira cache memory. Its frequency is 700 MHz to 1.2 GHz. It has a 200 MHz and the latest socket A with 266 MHz FSB, using 100 and 133 MHz by default twice, and looks like a socket A with a processor socket. The Celeron 2 Coppermine 128 processor uses 128 KB of 2 Lira cache. It can be connected to a 66 MHz or 100 MHz FPGA motherboard and operates at 533 to 766 MHz and 800 MHz, respectively. The Cyrix Mali processor is being remanufactured by VIA, which already runs on a 100 MHz socket 7 motherboard at 433 MHz. The Duran Spitfire is AMD's latest motherboard processor with 200 and 266 MHz FSB and socket A slot that includes 64 KB of 2 Lira cache. Its clock signal also reaches 850 MHz. The Cyrix 3 processor is entirely a development of VIA. It works on 100 and 133 MHz motherboards with 500 and 600 MHz frequencies. Use AMD 3D instruction set. Due to its low power consumption, only 10 watts, no fan is required for cooling, a larger heat sink is enough. Intel's Pentium IV processor, released in late November 2000, operates at 1.3, 1.4, and 1.5 GHz on a motherboard with a 400 MHz FSB. It has a new SSE2 instruction set that contains 144 new instructions that support 3D rendering. In March 2001, AMD introduced its latest Athlon Thunderbird processor, which operates at a clock speed of 1.3-1.33 GHz. Of the PC hardware devices, the processor is evolving most dynamically. An 8086 XT processor takes approx. 30,000, a 6x86MX processor is approx. 6 million, an Athlon Thunderbird processor is approx. It consists of 37 million transistors. These devices are already LSI, large-scale integrated, or VLSI, very LSI, technology circuits. ICs that contain 100 to 100,000 transistors are called LSI circuits, and those that contain more than 100,000 transistors are called VLSI circuits. Processor structure and operation. Step 1. Program start addressing. Step 2. Search for next command in memory. Step 3. Read command in memory. Step 4. Search operand in memory. Step 5. Read operand in memory. Step 6. Operand control. Step 7. Write result to memory. The relationship between the processor and main memory. The CU and the ALU in the CPU send command to the central memory, and the central memory send datas to the ALU.